All right, the next thing we want to do is to work towards applying transformations to sine and cosine. So as a kind of intermediate step, I want to go through some trig-specific vocabulary that goes with our transformations that I think is fairly helpful. So I've included this A, B, C, D to represent all the different stretches, compressions, and shifts. I'm going to ignore reflections a little bit here. Those tend to be fairly easy and there's no specific vocab that goes with those. So just remember that if A is negative, that means that there is a vertical flip, so a flip over the x-axis. And if B is negative, that means that you're flipping over the y-axis. Okay, so other than the flipping piece, what A is typically going to tell us is there a vertical stretch or compression? So A is multiplied by the function. So this is going to be vertical stretch or compression. So what we're thinking here is if we have this sine wave, and this would all work for cosine as well, and we apply, say, a vertical stretch, the top of the graph is going to get higher and the bottom of the graph is going to get lower. And that's what vertical stretch is looking like. And the trig specific word that goes with this is amplitude. This is affecting the amplitude of the graph. And amplitude means from the middle, how much do you go up and down to hit your maximums and minimums. So from middle is kind of important. Okay, B is my next one. B is horizontal stretch or compression. And this is going to be really important as well. What this is going to change is the period of your function. So this is where things start to get interesting when we break away from the unit circle a little bit. We can make a sine or cosine function that doesn't have a period of 2 pi, even though that was our starting place, was on the unit circle where you always have to go 2 pi to get around. We can do things that make us travel around the circle slower or faster is how I would think about that. And that's the horizontal stretch compression of the graph. So this one's a little trickier to say. I think it does actually have a name, but I don't ever remember it or use it. What I would remember here instead of a specific word is that B is related to the period. So B is always going to be 2 pi divided by your period. I'm just going to use P that we used earlier. And you can solve that for P as well. And interestingly, since it's just this nice simple reciprocal relationship, it just switches the P and the B. And basically what that's saying right there is that, for example, if B is 2, that's actually horizontal compression. Remember that all the things affecting X are backwards. Horizontal compression by 1/2. And you can see in the formula, if B is 2, the period gets divided by 2, which means the new period is pi. So compressing by 1/2 is making your period shorter as well. We'll get lots of examples of this. I just want to get this list down for you. Okay, the C, we're adding and subtracting C to our X's. So this is going to be shift, and it's left or right. We're shifting our X values. And again, remember the backwards. If it was +2, that would actually be to the left 2. And if it was -2, that would actually be to the right 2. This does have its own specific name. This is called phase shift. And I do tend to forget which one's negative and which one's positive for phase shift. But if you just remember phase shift as in shifting where you're starting your wave, I think that's a little bit helpful. And then the last one is D. D represents shifting up or down. This is added to your function. So that's going to be vertical shift, shift up or down. And what this affects is where the middle of your wave is. All these basic wave shapes we've been looking at have had their vertical center on the x-axis. So they go up one from the x-axis and down one from the x-axis. If we shift up or down, it's that middle of the graph that changes, and that middle of the graph is called equilibrium. And so what I want to think there is vertical center, not horizontal, but vertical center. So where is the middle of your graph in terms of the y values? Okay, so that's our vocab list. And from here, we'll go ahead and start applying these things.